All right, everybody. Hope you're having a great day today. And today we're going to actually start by talking about perpendicular vectors again. I know it seems somewhat redundant, but we're going to look at each of these in a different way so that maybe we can make our lives a little easier and a little shorter in terms of workload. So in particular, yesterday we talked about how to find a perpendicular vector, and we even just, well, we had to kind of take this apart, write the vector, and in this particular case, we said, okay, we know that the vector for this one would have been, well, let's just say 4, -3. Okay, once again, reminding you of the change in y over change in x being here on the bottom, and so that's why that 4 would go first. So if I wanted a perpendicular vector, as I said, you switch and negate one of them. So if I was to do that, do you all follow that that would be the vector 3, 4? Now, as you're looking at this equation, something else that's quite unique about this is I could write this in a different form. It's what they call the general form. Hence, this little dude over here, isn't he cute? He's the general. Yay. If I was to write this in general form, what that basically means is everything is on one side and it's set equal to 0. So let me just demonstrate this. So that would mean that the first thing that I'm going to do is I'm going to subtract the 2. So I'd have y minus 2 and -3/4 x. Then what would I do to get everything on the other side? How would I bring this guy over here? And you might think, hey, can't we just add that 3/4? Yeah, but let's just get rid of that fraction even in and of itself. So what I'm going to do, even before anybody might suggest something different, I'm going to multiply both sides by 4. When I multiply both sides by 4, that helps this whole situation in getting rid of that fraction. So I'd have 4y, I'd have -8 on this side, and now the -3x. So now I'm going to bring that to this side. So I'd have 3x plus 4y minus 8 equals 0. This is what we call the general form. You don't need to salute it. All right. Now, how, or rather, what do you notice is the relationship between this perpendicular vector and that equation? Maybe you don't see it quite yet. Take another second, look at it, see if you can figure it out. All right, now I'm going to change gears on you. I'm going to now look at this general form in another way. In fact, I'm even going to save this for a little later here. I don't know if you saw that, but I'm going to hold on to that. And I want you to look at the homework question that you have there, 23b. If you look at it, it told you to write 2x minus 3y plus 6 in y equals mx plus b form. So let's do that. Let's write that so that y is alone. So what might be the first thing you do? Kind of hoping you tell me that you're going to move this guy over there and you're going to move this guy over there, and I'm not sure which order you might have thought that through by, but I would have a minus 2x and a minus 6. And then what would you do? Divide by -3? Wonderful. So I'd have 2/3 x, and divide by that -3, we get +2. Do you all follow that? Great. Now it says find the slope. So what is the slope? The slope we hopefully can see pretty quickly by looking right there and saying, okay, it's 2/3. So what would be the perpendicular slope? The perpendicular slope would be to negate and flip, negative reciprocal. So that'd be -3/2. Now let's link that with that general form again. If you'll notice, the change in y, -3, and the change in x, 2. It's beautiful. Great. So now, hopefully, you're prepared for this lovely rule here. I'll just clear the ink here. Move this down. Now let's look at this rule. Basically, what is observed here is that the vector AB is perpendicular to the line that's represented here. Let me say that again. The vector AB is perpendicular. In other words, the vector AB, the A and the B here, represent the vector that's perpendicular. So if an equation is given to you the general form, then what you have to understand is to pull that x value and to pull that y value would be the perpendicular vector, not the actual vector of that line. So be very careful. Okay, so I give you another example of this. Let's just try one more, just so maybe those of you that are still kind of not catching it yet, maybe you'll see it. It says, find the slope of the perpendicular line. Well, the slope of the perpendicular line here would be, excellent. Aren't I just so good at this? Write the vector of this line. Well, the vector of this line that we have right here, change in y, change in x, would be 3, 2. The perpendicular vector would be, looks as though in my case, 2, negative 3. Again, that negative could have gone to either. Write a parallel vector. Parallel to b, parallel to that one would be any multiple. I'm just going to, again, express that as 3a, 2a. So you understand it could be any multiple that anybody might be shouting out at any time here. So any multiple there. Okay. Now let's do a whole host of examples. It says find a vector perpendicular to the line. When we want a perpendicular vector, if it's in the general form like you see here in A, it's very simple. You just write that puppy down. You've got negative 5 for the x, you've got 3, that's the perpendicular vector. So let's look at the next one. And it really didn't matter that in this case the 5 is on this side. It really doesn't matter. We could move it to the other side so that you can look at it that way, but let's be honest, it has no effect on the vector itself here that we can see. There's my perpendicular vector. When we see it in the Cartesian form, where it's set equal to y, this one we have to understand, okay, the original vector that we have here, change in y, change in x, is 3, 2. So if I want the perpendicular vector, I don't want 3, 2, I want negative 2, 3. Or yes, 2, negative 3. All right, this next one here is tricky. Because when you look at, and it says y equals 1, understand what this is really saying is 0x plus y equals 1. So that basically is saying that the x part of that vector is 0, 1. And this is in the general form, which is kind of lovely, actually. And so there's my perpendicular one. All right, the next one. We have E, which says x equals negative 3t. This isn't in our Cartesian form, but we can see the vector really easily. And so if I want that perpendicular vector, again, switch and negate. And that's what you have to do. Does that make sense? Great. That's all I have, I think, today. Oh, no, I guess not. Tricked me. So let's consider these two. In general, the line, your parametric equations, in general, we're going to look now at parametric equations are always set up in this form. Ax plus b, and then the cx using just different letters. So that has an initial point. That means when time is 0, when, in this case, x would be 0, its initial point would be BD. And it's in the direction of AC, in that parametric. And it would be parallel to anything, any multiple of AC. So let's look at this. These two equations that you have in front of you are actually both starting at the same initial point. Both of them have the same initial point. In fact, these are parallel vectors. If you notice, the vector of the first one is 2, 1. The next one is negative 2, negative 1. It's just a scalar multiple of that. And so just kind of emphasizing the fact that although they look a little different, they are the same in the sense that they are parallel lines. They have the same initial thing going on there. So, all right, any questions about that? If so, please save them, write them down. I encourage you, if you're taking notes and you're listening to this outside of class, write down your questions. Please bring them into class, and I'll be more than happy to answer them when I can. Have a great day, guys.